So let's have a look at balancing a redox reaction in an acidic solution. And we'll take the example of iron, 2+ ions in solution, reacting with a permanganate ion in solution to give us iron 3+ and manganese 2+ in solution. First step we need to do is establish what part of the reaction is oxidised and what part is reduced. So to do that, we add our oxidation states. Iron 2+ has an oxidation state of +2. Our oxygen in our permanganate ion has a -2. We've got 4 lots of that. We've also got a minus here. To balance everything, our manganese must have an oxidation state of +7. Our iron 3+ in solution has an oxidation state of +3, and our manganese 2+ has a +2 oxidation state in solution. So from that, we find that if our iron 2+ goes to 3+, our iron 2+ is oxidised, and our manganese in our permanganate ion goes from +7 to +2, therefore it's reduced. What we now need to do is set up our half reactions. So iron 2+ going to iron 3+ is oxidised because it loses an electron. Manganese or permanganate, the manganese goes from +7 to +2, so it's reduced. What we now need to do is balance for the atoms in solution. So if we start with our first half reaction, our iron 2+ to 3+, we don't need to balance any other atoms. So it's balanced for the number of atoms. On the other hand, the permanganate is deficient in oxygen in the products. So what we have to do is, the first step is to make sure that the manganese has the same number of atoms on both sides, and in this case it does. So we can move on to balance our oxygen. So we've got 4 oxygens on the left-hand side, so we need to add 4 lots of water on the right-hand side, the deficient side. Now we're deficient in hydrogen on the left-hand side, so we need to put in 4 lots of hydrogen ions on that left-hand side. We've now got 8 hydrogens on the left, 8 hydrogens on the right. 1 lot of manganese on the left, 1 lot on the right, 4 lots of oxygen on the left, 4 lots of oxygen on the right. So we're now balanced in terms of our atoms for both half reactions. The next step is to balance our charge, and we do that by adding electrons to one side or the other. So if we take our first half reaction, iron 2+ to iron 3+, we've gone from 2+ to 3+, so we've lost an electron, and we place that electron on the deficient side. In our second half reaction, we've gone from +7 on our manganese to +2 on our manganese, so we've had to take in 5 electrons to do that. So we add the 5 electrons to the left-hand side of this equation. So our equation here is 5 electrons plus 8 hydrogen ions plus 1 permanganate ion now gives us 1 manganese 2+ ion plus 4 lots of water. What we now need to do, after we've got our 2 half reactions, is to add those is to balance out the number of electrons on both sides. So if we look at this particular reaction with this particular reaction, we find that we've got 5 electrons here, only 1 electron in the first reaction, so we need to multiply this part by 5. So we get 5 lots of iron 2+, gives us 5 lots of iron 3+, plus 5 electrons. We can now go about adding the 2 reactions together. And if we do that, we get 5 electrons from the left-hand side of this reaction, plus 8 hydrogen ions, plus 1 lot of permanganate. We also add in our reactants from the second reaction to give us 5 lots of iron 2+, and this all goes to, for our products, 5 lots of iron 3+ from our second reaction, plus 5 electrons from our second reaction, plus 1 lot of manganese from our first reaction, plus 4 lots of water from our first reaction as well. And the next step is to cancel out those species that are common to both sides. So if we look through, we have 5 electrons on the left-hand side, 5 on the right-hand side. As we go through, we don't have any protons or hydrogen ions on the right-hand side, so that one stays. Our permanganate ions we don't have on the right hand side, so that one stays. Our iron 2 plus we don't have on the right hand side, so that now stays. So if we look at our balanced reaction now, we've got 8 lots of hydrogen ions plus our permanganate ion plus 5 lots of iron 2 plus ions gives us 1 lot of manganese 2 plus ions plus 4 lots of water ions plus 5 lots of iron 3 ions. Now we're not quite finished. We need to balance both the number of atoms and the charges on both sides. So if we look to the reactants first, we have 5 iron atoms, we have 8 hydrogen atoms, we have 1 manganese atom, and we have 4 oxygen atoms. We also, on the right hand side in the products, we have 5 iron atoms, we have 8 protons coming from 4 times the 2 there, we have 1 manganese atom, and we have 4 oxygen atoms from our water. Almost finished. We now need to balance for the charge. So if we look to the left hand side, we've got 8 times plus 1 minus 1 gives us 7, plus 10 gives us plus 17, positive 17. Let's look at the right hand side. We've got 2 plus 5 times 3 plus gives us plus 17 as well. So if we look, we're balanced for the iron, balanced for the hydrogen, balanced for the manganese, balanced for the oxygen, and balanced for the charge. So that reaction is now a balanced reaction in an acidic solution.